Hi everyone, and welcome back to Skill 9, where we're going to be talking about density calculations using molar quantities. So you should already be familiar with the two molar quantities that we're going to be using today. The first one is the molar mass. And when I say molar mass, all I mean is the GFM. And a molar mass has units of grams per mole. The other molar quantity you should be familiar with is something that we've talked about earlier in this unit when I told you about the molar volume. The molar volume of any gas is always the same. It is always 22.4 liters at standard temperature and pressure. So that means that any gas has 22.4 liters in 1 mole. So the units here for molar volume are liters per mole. So if we're just talking about a mole of something, it is relatively simple to do this calculation to get the density. A density is a unit of mass per volume. And so molar mass, which is grams per mole, if we're just talking about 1 mole, then it's just grams. And if we're just talking about 1 mole, it's just liters. So all you need to do is take the molar mass, or the GFM, and divide that by the molar volume, which is always 22.4 liters. That never ever changes. So that's it. If by chance you see something that in the problem is giving you different numbers of moles or different grams, that actually doesn't even matter, because regardless of how many moles or how many grams of the substance you have, the molar mass is still always the same and the molar volume is still the same. So you can still just use the GFM and the 22.4 to calculate a density. So let's see an example of this. So in my first example here, what is the density of 1 mole of water? So the GFM of water is 18 grams per mole. So that really just means that 1 mole of water weighs 18 grams. The molar volume is 22.4 liters in 1 mole. Again, that just means that 1 mole of a substance takes up 22.4 liters. So to calculate the density of this water substance, all I'm going to do is take this GFM value, 18 grams, divide it by the 22.4 liters, and when I do that division, I get the density is 0.8 grams per liter. So that's it. It's just a simple density calculation, mass over volume, but the volume in all of these cases will always be 22.4 because we're talking about the molar amounts, or how much is in 1 mole of a substance. So can you try the next one and see what you get? Okay, did you get this as your final answer? Hopefully. So let's try the next one. So for number 3, the question is, what's the density of 2 moles of NaOH? So the thing to be careful of here is that the 2 moles actually doesn't matter. So you can still just find the GFM of NaOH and use that to calculate the density. Go ahead and try that now. Okay, did you get this as your final answer? Hopefully. Okay, so let's try a slightly different version of this same problem. So another version of this problem would be that if I tell you a sample of nitrogen gas has a density of 1.25 grams per liter, and now instead of finding the density, I want you to find the molar mass. So the equation is still the same. Density equals molar mass divided by molar volume. So I'm telling you in the problem that the density is 1.25 grams per liter. So that goes in the density position. That equals a molar mass that I don't know yet. So that's my X, or unknown value. And I'm going to input the molar volume of 22.4 liters on the bottom. And if I cross multiply these two values here, I wind up with a molar mass of 28 grams per mole. Okay, so I want to see if you can do the next one. On this next problem, I'm asking you to calculate the molar mass, and then based on that molar mass information and on the fact that this has sulfur and oxygen, I'd like you to determine what the formula is of this compound, meaning how many S's and how many O's. So give that a try right now, and let's see how you do. Okay, is this what you got for your final answer? The molar mass was 48 grams per mole, and the formula should have just been SO, or if you wrote OS, that's fine too. Okay, give the next one a try. Did you get this as your final answer? About 18.7 grams per mole for the molar mass of the gaseous water. Okay, one last example to try, but I made a little bit of a mistake in the problem. This should not have read 4.75 for the density. That should have read 5.95. And I made another mistake. That should say 5.95 grams per liter. So use the 5.95 as the density value and calculate the molar mass again for this compound, and again what the formula would be if the density was 5.95. Give that a try and let's see what you get. Okay, so if you use the 5.95 as the answer, you should have gotten this. Where the molar mass was 133.3 grams per mole, and the formula should come out to be AlCl3. Okay, that's it. Hopefully this was pretty easy and straightforward for you, and so I'll see you on the next one. Have a good one.